Hi, I'm Lucy, and I'm really excited to be talking to you all today about web APIs, and in particular, how to access them from the comfort of your R console. So, in case you want to follow along with my slides while I'm going through this, you can find them at bit.ly/lucystats-jsm 2018. So here's a quick outline of where we're going. First, I'm going to give you a broad overview of web APIs in general. So for those of you familiar with web APIs, this will definitely be a review, but I think it's important to kind of lay out those definitions right from the get-go. And so I'm going to spend about 7 minutes on this portion. And then I'll spend about 7 or 8 minutes showing how you actually access these web APIs from R. So this will be more of the nitty gritty. I'll have some real code here so that you can see how you can actually implement this. And then finally, I'm going to go through some case studies where I'll show you some neat things you can do from R accessing web APIs, and I'll link to code so that you can try it later yourself. All right, so let's get started. What is an API? So API stands for Application Programming Interface, and this is a pretty broad term, but basically it's just a set of clearly defined methods of communication between some various components. So this need not be a web API. For example, the way that an R package is built, R packages have their own APIs. But a web API specifically is an application programming interface for a web server that allows you to programmatically access some resource. So the problem at hand here generally is that you are an individual user on your personal computer, you have access to the internet, and you'd like to access some resource on the web. And so first you have to figure out how you can actually make a request to access that resource. And then you have to figure out how you can get that resource back to you. So I'm going to focus first on this top part, making that request. The requests that I'm going to be talking about are made via these hypertext transfer protocol methods, or HTTP methods. And so these are 5 of the most common HTTP methods. Sometimes people call these verbs. And so I'm going to go through just what each of these do. First one, get, is a way to read or retrieve a resource. And so for example, if I were using the Twitter API and I wanted to pull all of the tweets that have a certain hashtag, I would use a get method to do that. And the next is post. And so a post method is for creating a resource. So for example, with the Google Drive API, if I wanted to upload a new file to my Google Drive, I would use a post method. And then put and patch are both ways to update a resource. And so put replaces a resource and patch will modify a resource. And finally, delete will delete a resource. So that's the way we make these requests via these HTTP methods. And that covers the first step of being able to build a API request, choosing the method that you're interested in based on the task that you're trying to complete. So these web servers have built a set of URLs that return data. And so after you've chosen the method that you want, you need to determine where within their set of URLs you want to actually access. And so to do that, you need to do a little bit of detective work to figure out exactly what it is you're trying to find. And the best way to do that is via the documentation. So each of these web APIs will have some developer docs that are generally pretty easy to find by just Googling for them. So for example, this is what the developer docs look like for Twitter. You can find them at developer.twitter.com. Here's another example for the Google Drive API. You can find those docs at developers.google.com. And here for the GitHub API, you can find those docs at developer.github.com. All right, so this server, they have this set of URLs that return data, and this data is often in a certain format. It's often JSON, sometimes it's XML, but for this talk, I'm going to be focusing on when the server returns JSON as the type of data. So JSON stands for JavaScript Object Notation. And basically, it's just a lightweight data interchange format. It's something that's pretty easy for humans to read and write, and similarly easy for computers to parse and generate, which is why it's so popular in this space. So here's an example of some JSON that was returned when I made a call to the Twitter API. And so for this particular call, I used a get method, and I went to the Twitter docs and I found the URL that I needed to send to in order to be able to retrieve all of the tweets that had the hashtag JSM2018 in them. And so this was the most recent tweet with that hashtag as of Thursday, July 19th, when I made this poll. And you can see that just looking at this JSON, it's relatively human readable. So I can pull out the different pieces by just kind of looking at it. So these are generally made up of name and value pairs. So for example, the name created at takes the value, this date that this particular tweet was created at. All right, so we've covered now the first two steps in building an API request. The first being choosing a method, and then the second being building that URL. And we've also covered how that data is going to come back to us, often in the format of JSON. So finally, once we've chosen our method and found the correct URL, we need to prove that we are who we say we are, that we have the credentials in order to be able to access the piece of this web server that we're trying to access. And so to do that, we need to have some kind of authentication. There are a couple different ways to deal with credentials with web APIs, but for this talk, I'm going to focus on OAuth, which stands for Open Authorization. And OAuth was first released in 2007 as an authentication method for the Twitter API. But basically, it just gives users the ability to grant third-party access to a web resource without sharing a password. So it's designed specifically to work with HTTP, so good for our use. And it'll basically just give you this access token that you can then send along with your API request. So those are the three main steps for building an API request: choosing a method, building a URL, and getting authorization. So that brings us to the second part of the talk: how are APIs accessed from R? So the main package in R that's used to access web APIs is the HTTR package, or some people call it the header package. And this package has functions that let you do those three steps that we discussed in the previous section. Basically, it has a lot of low-level functions, and so there are a lot of packages that wrap HTTR functions in order to take care of some of that heavy lifting for you. And once I show you how to do this with HTTR, I'll then show you how some of these packages take care of a lot of that for you. So depending on if you want to be building these queries yourself or if you'd like for a package to take care of it, will determine whether or not you're going to be using this package or maybe one of the higher level packages. So I'm going to kind of lay out how you can do each of these three steps in the HTTR package, and then I'll show you how to actually make a request and process a response using that same package. As a motivating example, I'm going to use the GitHub API. And in particular, I'm interested in looking at the Google Drive repository and pulling URLs for issues that have the label docs. So if I were doing this from the browser, I would navigate to the GitHub website, get to the Google Drive repository, click on issues, and then under filters, I would filter, is the issue open and does it have a label docs? And when I do that, I get three issues. And so I'm basically trying to replicate this, but from my R console using the GitHub API. And the thing I'm hoping to get in the end is a URL for each of these three issues. So HTTR has a function for each of those HTTP methods that we previously spoke about. And for this question, I'm going to be using the get method, because essentially I'm just trying to retrieve some data from the GitHub API. I want to get the URL for three issues, each of which have the docs label from the Google Drive repository. So that covers our first step. We've chosen the method of interest, and now we need to build a URL that can actually access that part of the GitHub API. So the main function I'm going to use from the HTTR package to build up this URL is the modify underscore URL function. And I think of these URLs as having three main components. The first is known as the base URL. And so this is unique to each API that we're going to be trying to hit. So for example, here for the GitHub API, it's api.github.com. And we're going to stick that base URL into the URL parameter of the modify underscore URL function. This base URL is quite easy to find via the developer documentation that we spoke about before. The next part of the URL is known as the endpoint. And so this tells the web server where the resource is that you want to access. And again, these endpoints are specified in the developer documentation. And so in this case, I looked at those docs and I saw that in order to pull issues, I would use the endpoint repos, and then I'd need to state the owner of the repository, and then the name of the repository, and then finally issues. And so I plugged in my case, Tidyverse as the owner of the repository and Google Drive as the name of the repository. And I put that in the path parameter of the modify_URL function. So the last part of the URL are the parameters. And these are optional and basically let you tell the API specifically if you want to retrieve just a piece of the resource back. So in this case, I'm just interested in issues that have the label docs. And so I went to those developer documentation files and I found that in order to do that, I need to use the labels parameter and I tell it which label I'd like to access. And so in the modify_URL function in R, we're going to stick these parameters in a list under the query parameter. So in theory, we could just write this URL out as a string and insert that into R rather than systematically building it up with this modify_URL function. But I think functions like this are really smart because they eliminate some probability of error. And they also let you utilize some nice tools. For example, in the Google Drive package, we hold all of our endpoints in a nice list that we automatically pull from Google. So if they ever update any of their documentation, we can make that list automatically update rather than having to navigate to those docs ourselves each time. And then we can plug in pieces of that list into this type of function. Okay, so we've completed the first two steps. Now we just need to get authorization. All right, so let's get authenticated. The first step to do this is registering an OAuth application. And so each web API will generally have a mechanism for you to do this on their website. So for example, for GitHub, I go to github.com/settings/developers, and I can register one of these applications. And once I've registered it, I can then create an OAuth application in R, so I can let R know that I've done this. And so to do that, I use the OAuth_app function from the HTTR package, and I plug in the app name, key, and secret that I just obtained from registering this application online. And then finally, I need to generate a token that I can send along with my request. And so to do that, I use the OAuth 2.0_tokens function, and I plug in that app that I just created. You probably notice here that I'm using OAuth 2.0_token, which implies that there is likely a 1.0_token as well, and indeed there is. And so it turns out that 2.0 is used for a lot of APIs, so Google, Facebook, GitHub, they all use 2.0. But there are some that still use 1.0. For example, Twitter uses the OAuth 1.0. So the HTTR package actually has a lot of demos for different cases, and it's super helpful. So it tells you exactly how to get this OAuth authentication off the ground so you can get that token. And so it specifies, if you click on each of them, they'll tell you which OAuth, what version, if you should be using 1.0 or 2.0. And they also will tell you where to navigate to on the web in order to create that initial OAuth application. So this is great. This is a really useful tool in order to be able to get authenticated. If your particular API that you're interested in isn't listed here, all of the information you need is generally within those developer docs. And so you can usually figure out from that, which authentication you actually need. All right, so we've completed those 3 steps. And so now we can go ahead and make that request. So we're going to use the get function from HTTR. So that's the method that we're interested in. And so that is the function we'll use to make our request. And then we plug in that URL that we created using the modify_URL function. And we also plug in that token that we just created. And here's what that will look like once we've made the request. So we're going to get back an object, and it's of type response. And the top has some just metadata about what we sent. And so it has that URL that we sent. It has the date, the status, the content type, and the size. And then underneath it, this should look kind of familiar. So this is that JSON that we talked about previously. So this is what was returned back to us based on the request that we made. And so again, this has that name value pair where the name is URL and the value is the URL for this issue. But then we have a lot more than just that first one. We have a lot more name value pairs. So for example, we have the repository URL, and there's a lot more in this JSON that we would need to parse through. And so we need to figure out how to make this into something that R can work with. And so that brings us to processing the response. So HTTR has a function called content, which is great for being able to parse these responses into something that R can interpret. And so we'll run that on this object rec that we just created. So looking at what that gives us, it gives us this nested list. And that makes sense because JSON kind of looks like a nested list. And so it's logical that that would be how R would best interpret this type of data. And so we still have those name value pairs. So you can still see URL as the name and the value as the actual URL that we're interested in. And this nested list is quite long. So I've only shown you 2 elements, but it goes on and on, for each individual issue. So how can we pull that out in a way that will be computer readable? Well, since it's a nested list, I'm going to suggest using per. So this is definitely not a per tutorial. I'm just going to show you how I solve this particular problem. And I do that using the map_chr function. So I'm going to map over that nested list called res, and I'm going to pull out just the URL because that's the piece of that list that I'm interested in. And I'm using the map_chr function because I want to get a character vector back afterwards. And indeed I do. So there we go. We have our 3 URLs for the 3 issues that have the label docs. And we've successfully used the GitHub API in order to access them. So now we've done all of these pieces. We've worked through how to do this using the HTTR package. And as I mentioned previously, there are a lot of packages that actually wrap those HTTR functions. So they take care of a lot of that heavy lifting for you. Depending on the package, they'll take care of more or less of it. But I'm going to show you a little bit about how one of these packages does this. So here we have the Google Drive package. And this is a package that Jenny Bryan and I have been working on. And essentially, we take care of a lot of that heavy lifting for you. So we choose the method. We are able to select the endpoint or the URL that you need in order to access the resource that you're requesting. And we also take care of that authorization, the authentication token. So you don't have to think about any of that when you're running any of our functions. So for example, if you were interested in listing all of the files on your Google Drive, you could install this package, load it using library Google Drive, and then just run the drive_ls function. And this will print to your console. It'll say waiting for authentication in the browser, and a browser will automatically pop up. And that browser will ask if it's okay for us to access your Google account. And if you allow it, then we're going to create that token for you. So you don't have to worry about creating that OAuth application on the website. All of that is done just by clicking allow. So once you click allow and then return back to your R console, you'll see that the authentication is complete, and then we'll go through each of your Drive files and we will put them in a nice tibble and print them out. So not only are we covering the choosing of the method, URL, and also the authentication, but we're also processing that nested list that we would get as a return object into something a little bit easier to manipulate in R. So we have this nice tibble where you have one line for every file on your drive. All right, so that brings us to our final section, case studies. So this first one I thought was kind of pertinent because it's one that I used actually for creating this talk. I was interested in letting somebody look at my slides and add some comments, and rather than having to send my big file, I wanted to just be able to send them a link to Google Drive. And so I called library Google Drive, and I used the drive upload function in order to upload my slides. So I could specify exactly where on my Google Drive I wanted those updated with the path. I can specify the name I want these slides to have. And then finally, I can specify the type. And so this is really nice. This lets you convert your files into a Google Drive type. And so when I use type equals presentation, it'll convert the PowerPoint slides into actually a Google Slides type so that people can go ahead and add comments via the Drive client. Another example that I do a lot with Google Drive is organizing my drive from the comfort of my console. And so this just kind of speeds up that process. My drive was really unwieldy. I had tons of files everywhere, and none of them were organized very nicely into nice folders. And so I was able to organize them pretty systematically using the Google Drive package. So for example, I just started a postdoc about a month and a half ago, and my advisor, Jeff Leake, and I were working on a lot of files, and they were sort of all over the place, and so I wanted to consolidate them all into a single folder. And so I did that by first finding all the files that he and I collaborated on together using the drive find function. And then I can create a new folder using drive mkdir. So I made this new folder, and then I basically just iterated over each of those files that I had pulled, and I moved them using drive mv into my postdoc folder. Here's one using the Slack API. So I was interested in looking at the rOpenSci Slack channel and what emojis were being used. And so I pulled that, and I saw the most frequent ones, and I plotted it. So if you want the code for this, you can find that on my blog, livefreeordichotomized.com. And here's another one, navigating Twitter responses. And so I find tweets to be kind of unwieldy when they get a lot of responses. It's hard to figure out, what all has already been said. And so this, for example, Hillary Parker had tweeted about whether or not it was appropriate to send a calendar invite to get coffee with a friend. And a lot of people had a lot of opinions. And so I used the Twitter API, and in particular the rtweet package, in order to pull all of the responses to her initial tweet, and then I was able to plot them. So this again is on livefreeordichotomized.com if you're interested in looking at it. And finally, Mayel and I worked on a project last year for the JSM Art Show, where we wanted to have a plot of everyone involved in the Our Ladies meetups. And so to do that, we pulled the profile pictures from everyone who had joined an Our Ladies meetup using the Meetup R package. So that's a package that's been built and developed by Our Ladies. And basically I pulled each of those profile pictures in, and then I matched the predominant colors using K-Nearest Neighbors so that we could organize them in the shape of the R logo. So that code also is on livefreeordichotomized.com. All right, so that kind of wraps things up. Thank you so much. I hope that you've been able to learn a little bit from this. If you'd like to look at my slides, you can find them at bit.ly/lucystats-JSM2018. And please feel free to reach out to me either on Twitter or via email if you have any comments or questions. Thanks.